Okay, here we are going to look into the definition of universal set. You can see here we are going to discuss two examples. So first example, there are three sets A, B and C. The element of set A is 1, 2, 3, 4, 5. Set B is 4, 5, 6 and set C is 9 and 10. So let us think about a set which contain all these elements from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this set which contain all the elements of A, B and C and maybe slightly some extra elements as well. But this is the set which basically describe all these three sets. All the elements of set A, B and C exist in this set. And this set is called universal set in this scenario. Okay, universal sets are normally represented by capital U or a symbol known as epsilon. So you can use any of the two symbols, either capital U or this symbol epsilon, to describe a universal set. Now you can see that all the elements of set A, which are 1, 2, 3, 4, 5, are here 1, 2, 3, 4, 5. So set A is a subset of universal set. Elements of set B 4, 5, 6. You can see they also exist in universal set. So B is also a subset of universal set. And then the elements of C 9 and 10 also exist in universal set. So C is also a subset of universal set. So a universal set, whenever a set fulfills the condition of a universal set in a given scenario, all the other set must be the subsets of universal sets. Okay, let's look into the other example. There are three sets again: A, B, C, D, set X, set Y, A, E, I, O, U, which are vowels, and set Z, P, Q, R. So if we have a set which basically contain all these elements, and doesn't matter whether it is bigger than these three sets, I mean it has more elements, so it is okay. So if I say that all the alphabets A, B, C, D, E until X, Y and Z, so this fulfills the definition of universal set in this case. All the elements of set X, set Y and set Z are existing in universal set U. Okay, so universal set basically depends on the given scenario. So it must be true that all the sets in given scenario must be the subsets of universal set. So X is a subset of U in this case. All its element A, B, C, D, you can see that they exist in universal set. A, E, I, O, U also exist somewhere in the alphabets, and P, Q, R also exist somewhere in the alphabet. Okay, so Y is a subset of U and Z is a subset of U. Okay, right. So then there is another short definition of empty equal sets. Equal sets. So if we have two sets A, 1, 2, 3 and 4, and then another set B which contains 4, 1, 3, 2. Basically you can see that both of these sets have same elements, even though the order of element in set B is different. So it doesn't matter if even the order is different, but if the elements are exactly the same in any order, then the sets are equal. And in that case, you can also say that A is a subset of B and B is a subset of A. This is a small definition about equal sets. Now let us perform different operation on sets. So first one is known as intersection. Intersection of two sets, and it is represented by this sign. Consider two sets. One is A and 1, 2, 3, 4. Another set is B. It has element 3, 4 and 5. So intersection means A intersection B. It means the set of common element in sets A and B. So you can see that 3 is common in both and 4 is common in both. So our answer is 3 and 4. If you want to draw a Venn diagram for that intersection, you will draw two overlapping circles. One is A and one is B. So this overlapping part basically is the common part for both of these circles. So your common element will be represented in this overlapping part. And if you want to shade it, you can shade this part. So this is intersection. A intersection B is basically, in Venn diagram, you have to shade the common part of both overlapping circles. Okay. The next operation is union. As it is clear from the name, union means to combine both of the set. So A union B, combine all the elements of A and B together. So it is 1, 2, 3, 4. And in set B, 3, 4 is again there. You don't need to rewrite it because in set, repetition is not allowed. And the last element in set B is 5. So the union of A and B is 1, 2, 3, 4, 5. And the Venn diagram means each and everything. That's it. Okay. Two overlapping circle because there are common elements. So 4 and 3 will be part of, it should be written in the common part, and the rest of the element in A are 1, 2, and in B are 5. 1, 2, and 5. So Venn diagram for union is basically shading both the sets. All right. Another important operation is known as complement. Complement of a set A, for example. It is represented by A prime, A dash. It means not in A. So A dash means not in A. So basically, if you are given a universal set, and one more thing about universal set I would like to tell you, that universal sets are represented by a rectangle when you draw a Venn diagram for a universal set, not a circle. Okay? So if we have a universal set 1, 2, 3, 4, 5, and if we have a set A, element 3 and 4, so then A complement is equal to elements which are not in A. So elements of A are 3 and 4. So you can cut 3 and 4 from universal set. So what are the remaining element? 1, 2, and 5. You can see that these remaining elements are not the part of set A. So that is your answer for complement of a set. For the Venn diagram, you can just represent the universal set with a rectangle, and this is set A, which is inside the universal set because A is a subset of U, so A must be inside U. So the elements of A are 3 and 4, and element of U are 1, 2, 3, 4, and 5 because A contains in U, and you are not supposed to repeat. If you want to shade that, so by definition, complement of A means that everything outside A, everything which is not in A. So that is our shaded part in that case. So this is our answer in terms of Venn diagram. Everything, shade everything which is outside A. All right. And one more definition here is N of a set A. It means number of elements in set A. Number. Right? So for example, here in this case, A has 2 elements. So N of A is equal to 2. For universal set, in this case, there were 5 elements. So universal set has 5 elements. So number of elements of U is equal to 5. Okay. Now you should be able to do questions from exercise 2.